we will not have only one way to solve a system of equations. We won't have two ways to solve a system of equations. We're going to have three ways to solve a system of equations. So probably the most inefficient method is graphing. Okay? Graphing works really nice when we're in slope-intercept form and when we have an integer intersection. 1, 2. But if we have like a decimal fraction sort of intersection, it's going to be really hard to figure that out on a graph. Okay? Algebra, we're fine working with decimals and fractions. Okay? But substitution doesn't have to be our only algebraic method. We can do what's called elimination, where we take the two equations and we eliminate a variable. Okay? So let me just show you what I mean. Okay? So the first thing that's going to happen is we're going to look at our system of equations and we need to decide, do we have, bless you, a variable where the coefficients are opposite? Miles, give me an example of two coefficients that are opposite. Two numbers that are opposite.
Like 2 and -2?
Like 2 and -2. If the coefficients of y, 2 and -2, those are opposites. Okay? So, if we have opposite coefficients for our variables, then we can add the equations to eliminate the variables. What do you mean by that, Miss Homan? Let me show you. If I have x plus y equals 10 and x minus y equals 4, do I have a variable whose coefficients are opposite? Which one? Our y's are opposite. When this happens, watch this, we can add our two equations together. What is x plus x? What is y minus y? They cancel. And what is 10 plus 4? Okay. So now what we can do, we have eliminated a variable. We can solve this result. If 2x equals 14, what's x equal to?
7.
X equals 7. Okay. Now, how do you suppose we're going to figure out y? Plug it in, okay? We're going to substitute the value into one of the original equations. Now, do you think it matters which one we choose? No, because it's going to satisfy both. So we get to decide, which one looks more exciting, okay? What I'm going to do, I'm going to choose the first one. X plus y equals 10. What's y? Oop. Okay. Still a bunch of marks on the board. Sorry, guys. Okay. Now, the trouble will come if I give you two equations where we don't have opposite coefficients. Then, you notice how I skipped over this step 1. If we don't have opposite coefficients, we are going to have to multiply one or both equations by a number to force that to happen. And I'll show you what I mean by that. Okay? But we may have to do a little bit of work before we can eliminate. Okay? I'm going to tell you right now, between substitution and elimination, I guess I've told you before, I just really like this chapter. Find it very satisfying. Okay? And, of course, will we know if we have the right answer? Yeah. Okay. Is 7 plus 3 equal to 10? Is 7 minus 3 equal to 4? Okay. So what I want you to do over on the next page, I just want to see what you can do. Can you take number 1? Do we have a set of opposite coefficients? Yeah. Our x's. Can you add these together and go ahead and solve for x and y? I'm cool if you talk to each other.
Does the slope for when doing like a substitution or graphing, when I was subtracting functions, one's negative, one's positive, would it just depend on what slope it is? I can just show you what it's called.
Joey, do you think you can ask me this question after notes so that we can focus on the next stuff? Okay. You got it? Okay. When you get a coordinate, will you put your hand on your head so I know? Is your hand on your head? Okay. I was just making sure. Oh, are we? Oh, wait, what? Stop. Here. I already dropped it.
You sat with me. Oh my God.
Okay. When we add these together, which variable eliminates? Okay, and we have 5y equals 25. So what is y? 5. Raise your hand if you plugged 5 into the first one. Raise your hand if you plugged y into the second one. Yeah, I think the first one is probably smoother. X plus 3y equals 17. So if x plus 15 equals 17, x is 2. So we have 2 comma 5. Okay. All right. So I am going to have you do number 6 and number 5.
Okay, so x cancels out here. Add. So it'd be 5y equals 28 plus 8, which would be negative 4. Y equals -4. Stop. My bad. Oh. I'm just like used to it when I'm working with the partner. You said I was your partner. Okay. But I don't know what it is. Wait, why does it look like this? -4. It should just be -4, -4. No. Oh, yeah. Wait. It would be -4.
What are you doing? Oh, wait, there we go. Come back to the charts. I know what I'm doing now. Let me check. No, 5. Yes. It's true. 13 minus 8. What do you mean? Add one line. Yeah. Same.
So the first one I probably need is 4.
Because then it would be 5 times negative 5 plus 2 times. Oh, wait. Oh, my Yeah, I'm still probably going to get the same. Oh, yeah, I got it.
I don't like math.
Okay, with your fingers, show me how many more minutes you need to finish 5 and 6. You need 2 minutes?
10.
Okay.
Yeah, every day. Jacob Tanner. I don't want to look at this. Oh my god. Mine goes down.
We should do number 8. Number 8.
My friends like you put it up and it stays like for a while.
What? 8?
You guys get for
I
one.
don't have one.
But
Next period, I can afford my. I don't look at me. But you guys got number 5. Stop. There's one more.
Negative 4. Negative 4.
Hater.
The pencil sharpener is currently not working.
That's all I want. Stop making veins, guys. I just scratched
Okay, we're going to go ahead and go over number 5. Okay. Aubrey, what'd you get for a solution for number 5? -4, -4. Okay. So if we add these together, we get 5y equals -20. So, yep, it looks like y is -4. How many of you plugged -4 into the first equation? Second equation. All right. So 5x plus 2y equals -28. So 5x equals -20. X equals -4. I like it. Okay. Willow, what'd you get for number 6? How do we feel about that? Okay, so now we're going to eliminate y, right? We get 5x equals -5. So x is -1. Raise your hand if you plug this into the first one. Second one. I like the second one because y has a positive coefficient. So 3x plus 5y equals -13. So 5y equals -10. Y equals -2. Very nice. Okay? How do you feel? Isn't this nice? I like this. I like this. Okay. Now, this has been like handed to you on a silver platter. Like, these were nice. Go ahead and turn the page. And we're going to look at problems where we have to do a little bit of work. Okay, please listen carefully to me. You have to be organized. You have to be organized. Okay? If you are not organized, you are going to make a mistake. Okay? So, my first question, do we have opposite coefficients? So we are going to have to choose a variable in order to force that to happen. Okay. Honestly, I think either one we pick is going to be the same amount of work. So let's take a vote. Who would like to make X opposite? Who would like to make Y opposite? Okay, not everybody voted. It looks like X's were our winner. Okay. If we want to make X opposite, what would we need to multiply this first equation by? Negative something. So right now, this coefficient is 2. What's the opposite of 2? So I need this to be a negative 2. Currently, it's what?
Multiply by negative 2.
So currently, it's 1. So we need to multiply that top equation by negative 2. Will you write exactly what I wrote? Will you write the 2 parentheses and that we're multiplying by 2? Okay. I am hearing a lot and seeing a lot of distractions. I need you guys to lock it in. Stop messing with my stuff. Stop messing with each other. We're focusing on the math. Okay, so if we multiply that first one by negative 2, I'm going to write it right here. Negative 2x. What's 2y times negative 2? Negative 4y equals 20 times negative 2. Okay, so please make sure that that negative 2 goes to all 3 terms. Okay, why do you think I rewrote it right there? So we can add them together. Okay, so notice how I stacked the 2? Where the x's are together, the y's are together, etc. So now, since our x's are now opposites, we can add the 2 equations together. So what happens when we add these? What happens to 2x plus negative 2x? We eliminate it, right? What about y plus negative 4y? Negative 3y. Remember, because that's like a 1. Okay. 19 plus negative 40. What? Negative 21. I thought I heard something different. Okay. Excuse me, Joey. All right, so y is 7. Okay. Now, let's go back to one of the originals. Which original problem would you like to substitute back into? Okay, I'm going to go with the first one. So 1x plus 2y equals 20. Does that mean x is 6? Okay, I heard some questions happening. Do I need to answer a question up here? Okay. Now, was this the only way to do it?
Yes.
No, that's the beauty of this. We could have multiplied the second one by negative 2, and then our y's would have been opposite. But guess what? We would have still gotten the same answer. So some of you might choose to make x's opposite. Some of you might choose to make y's opposite. It doesn't matter. Okay? So let's look at number 11. Okay? Number 11, it's pretty obvious that neither variable is opposite. Okay? Does anybody have any strong feelings about which variable we want to work on? You want to make y's opposite? Let's make y's opposite. Okay. Now, is this a time where we're just going to multiply one of our equations? Like, without using fractions, is there just one number I can multiply by to this first one to make y's opposite? No. Okay? And I'd like to stay away from having to multiply by a fraction. Okay? So we're probably going to have to choose a different number for each. But we're going to have to choose a number to multiply the first one and a number to multiply the second one so that these two are opposite. Do you have an idea? What should we multiply the first one by? Okay, so if we multiply this first one by -3, that would mean the coefficient of y is a +6. Do you agree? So then what would we multiply this one by? Jace? So I'm hearing +2 and I'm hearing -2.
Okay, but if the top one was multiplied by -3, then you would multiply the bottom one by -2, right?
Okay, do we want them both to be -6, or do we want one of them to be negative, one of them to be positive?
They're opposite, so one positive, one negative.
Okay, so if I multiply by -3, this becomes a +6. If this is a -3, what are we going to multiply by? We need a +2. Okay? Okay, so you need to show me the rewrite for both of these. I need to see, number one, the number you multiplied. Number two, I need to see you rewrite them. So our first one, if we were to distribute that -3 to all three terms, we have -9x plus 6y equals a +6. Do you understand where I got all of those numbers? Camden? You good? Okay. In our second equation, we're multiplying all of these numbers by 2. So for x times 2, -3y times 2, and -4 times 2. The whole purpose is so that one variable is opposite. Beautiful. Okay. Now, I want you to show everything that I have up here for a couple of reasons. The biggest one is that if you make a mistake, we can work on finding it together very quickly. If you don't show me what numbers you're multiplying by, if you don't show me your two new equations, I don't know how to help you. Okay? The most common mistake is missing one of those terms in your multiplication. Make sure you get all three multiplied. Okay? All right, so now let's do our elimination. When we add these together, the y's eliminate, and we have -x equals -2. Okay. Not only are you being distracting towards each other, you're being distracting towards me and the people around you. I need you to stop. What's x? X is 2. Well, if -x is -2, We would divide by -1, right, Joey? Okay. All right, doesn't matter which one you plug it into. No. I'm going to choose the first one because I don't want to think. I don't want to decide. Okay. So I have 6 minus 2y equals -2. Does that mean -2y equals -8?
Yep.
Okay. So our solution is 2, 4.
Yep.
Okay, sort of ran out of room to squish it in there. Wrote too big. Okay, so let's check. I mean, we did a lot of work. Might as well check. 3 times 2 is 6. Minus 2 times 4, which is 8. Is 6 minus 8 -2?
Yes.
Awesome. 4 times 2 is 8. Minus 3 times 4, which is 12. 8 minus 12? Okay.
It is the only time where we don't need to do both of them. We don't need to distribute on both.
Okay, that is actually a really good question, Joey. Joey asked, when do we not have to multiply both? Okay, so I'll give you 2 scenarios. Scenario number 1, if one of your coefficients is 1, then you would only have to multiply that equation. Okay? Scenario number 2 is if the coefficients are multiples of each other. So look at number 12. Do I have coefficients that is a multiple of the other one?
Yeah.
We do, 3x and 9x, okay? So in this particular problem, I would not choose to eliminate y. I would choose to eliminate x because we would only have to multiply one equation, and in this case, we would have to multiply it by -3. Okay? So now that we've made that decision, how about you finish out number 12? We're going to multiply the second one by -3. I want you to finish it out. Deal? Okay. Glad I could help. It's okay to get a fraction. Did I do that? No. There. Something's off. All right, so if you get 34y equals 17, I'm seeing some people work harder than they need to. When we divide by 34, please do not leave it as 17 over 34. 17 over 34 is the same as what? 1/2. Which means when we plug it back in, 9x plus 4y equals 11. 4 times 1/2. Well, that's pretty nice. Right? What?
No. X is 1.
Joey, you're full of crazy things to say today. Okay, so Joey, I really like that you asked that question because that's something that I want you to kind of look out for, okay? If you have a set of variables where the coefficients one is a multiple of another one, that's a good one to choose. If you have a set of variables where one of the coefficients is 1, that's a good one to choose. If neither of those things are happening, choose which one you would rather multiply the numbers by. Okay? All right. So